Hello, my name is Richard and I'm producing this part of the presentation on number sequences. Now, mathematics can be fun and it should not be frightening, and it should be enjoyable. Problems and challenges can be broken down into chunks that make it much easier to manage and to understand. Let's break away from the long and complicated ideas of formula or of language. Let's start from things we already know and understand. This is why I have chosen my topic on number sequences. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. These are all number sequences. They can be fun to investigate. So let's try. Football League Challenge. A coach ran a budding football team, but he had nobody to play against until one night, over a pint of beer, another coach joshed him about his team. All right, my team against your team. 2 games. If one team wins both games, the other one has to concede. If each wins a game, then we'll declare it a draw. You're on. Another team heard about this and they threw in their gauntlet. We would like to take part in this challenge. The first coach had a challenge. How many games will I need to organise? He came up with a devilish plan. He would enter the teams on a grid like this. As you can see, A cannot play themselves. Likewise, teams B. How many games would he need to organise? The following season, another team hears about the league and wants to join. Now there are 4 teams. Then another team joins to make 5 teams. He creates his grid and counts the games and comes up with a mathematical conundrum. 2 teams equals 2 games. 3 teams makes 6 games. 4 teams makes 12 games. 5 teams makes 20 games. Can you see any patterns emerging? He began to worry. What if 6 teams were to join? How many games would that mean? What if 12 teams were to join the league? How many games then? In his dreams, he had to create a league for 20 teams. Can you help the coach with his mathematical dilemma? Here's a hint. If there are 2 teams, A can't play itself, nor can B. So 2 times 2 is 4. You take out the 2 teams can't play, so that means 2 games. Now you might be able to see a pattern emerging. Now, 3 teams. 3 times 3 is 9. And 9, take away 3, is 6. So that's 6 games. 4 times 4 is 16. And 16, take away 4, is 12. Can you see the pattern emerging? If you can, how many games will he have to organise if there were 6 teams, 12 teams, or 20 teams? Now here's a new sequence problem, not so much different from the last. An ambassador was inviting people to a ball. It has always been customary to shake hands with guests. He really had a problem with handshaking, as he had heard that it was not good for infection control. 2 people shake hands, that's 1 handshake. 3 people shake hands, that's 3 handshakes. 4 people shake hands, that's 6 handshakes. 5 people shake hands, that's 10 handshakes. He knew he would be getting 50 people attending and everybody had to shake hands with everybody else. Headache! 2 people, 1 handshake. 3 people, 3 handshakes. 4 people, 6 handshakes. And 5 people, 10 handshakes. You can see that the number of handshakes were growing fast. No wonder most people wore white gloves at posh do's. Can you help him predict how many handshakes for 6 people, 7 people, 10 or more people? Can you see a pattern developing? Now let's look at the old football analogy. If you put in 2 teams, you get 2 games. If you put in 3 teams, you get 6 games. If you put in 4 teams, you get 12 games. And if you put 5 teams in, you get 20 games. Now look at the right-hand set of numbers. Can you see any relationship between the 2 numbers? If we go across from the football games to the number of handshakes, what happens to the numbers? 2 becomes 1, 6 becomes 3, 12 becomes 6, and 20 becomes 10. You create a formula to assist our worried ambassador to work out the headaches of 50 people all shaking hands with one another. The solution is not very much different from the football formula, except that a set of triangular numbers are emerging. 2 times 2 equals 4, then 4 take away 2 equals 2, then 2 divided by 2 is 1. 3 times 3 equals 9, then 9 take away 3 equals 6, then 6 divided by 2 is 3. 4 times 4 equals 16, then 16 take away 4 is 12, then 12 divided by 2 is 6. 5 times 5 is 25, then 25 take away 5 is 20, then 20 divided by 2 is 10. So it's number times number, take away that number again, then divide it all by 2. Here's the formula bit. N squared minus n divided by 2, or n brackets n minus 1, brackets, divide by 2. And so, if we have 50 people attending our function, that's 50 squared, take away 50, then divide by 2, will make a whopping 1,225 handshakes. And that's a lot of handshakes. Definitely a night for wearing white gloves.